Yeah, and it's not even difficult to do. That's the crazy part.
Wait, it's like guaranteed more life?
Yes.
Oh my gosh.
Yeah.
I bet that's so expensive.
No. It's just poop. Like, literally, they take poop from somebody young and healthy, and then they put that poop to establish a new biome in you. It's crazy, and it absolutely works, and hugely. Now, to be honest, because it's being done on billionaires, it's no telling what an effect like that would have on like somebody that doesn't have a team guiding them through the whole time. So we probably wouldn't, us, unless you're a billionaire, probably is not going to get 10 to 15 years out of that. More like probably like 2.5 to 5 years would be more reasonable. But still, it's like you're 50, now you feel like you're 40s. Okay. For all of you, it's not going to help, but you're all. Yeah. But it's the third largest determinant of aging, how you feel for aging. Okay. Do you guys know what the first two are? Genetics, number one. Number two is actually resting muscle mass. Yeah, it's exercise. And then number three is usually your fecal biome, though we're getting to parts where we could have big arguments and stuff when you start looking at science. Okay, so the matter is going to be anything that has mass and occupies space. It's going to make up all things we use. It'll be like water, wood, plastic bags, everything around you, right? The only thing you're experiencing that doesn't matter is probably light for most of you. Okay? We can classify matter according to its composition. So I want you to have sort of a branching split of matter in your head, okay? And we'll actually make a branching pathway that you can go through. It's this, then it's this, then it's this, okay? Boxes and boxes. So pure substances have a fixed or definite composition. Mixtures will contain two or more different substances that are physically mixed, but they will not be chemically combined. If you chemically combine it, it would make a new substance. Okay? So, this right here is matter overall. And that's what we start with. So, all matter can be split. It's split into pure substances and mixtures. I'm going to be honest. Basically... Sure.
Thank you.
Okay. So, one of the things I'll point out, though, is these definitions are the same as your book. And the video also is posted on the YouTube channel. And the slides are also posted on your Canvas, okay?
Oh, we tried to find the slides. I didn't find
They're on the homepage. Yeah. And what I'd actually recommend is you all print these off in note-taking configuration. It makes taking notes just easier, okay? Because then you have these things written down and you don't have to write them and, not pay attention. No problem. So, I'm going to be honest with you. Pure substances is something that is actually extremely difficult to find in nature. Okay? And so basically none of us in our everyday lives are ever going to encounter pure substances. They're always going to be a little bit mixed. But you can get pretty close on a few things for pure substances. Okay? So it's not useless to talk about. You're going to get pretty close, but you're never quite going to get there in real life. Okay? The elements, these would be things like, this is the example used in your book, and it's very ironic, okay? Elements like copper, right? You could have gold, you could have hydrogen, you could have helium. Helium actually is pretty close to a pure substance, by the way, because you can purify that really well. And some of the metals actually can get very close to pure, like aluminum. Aluminum coming out of like France, which is where a lot of the aluminum is made. It always has to be made where there's nuclear facilities because you need so much power to do it. Anyways, those can get very, very, very pure, almost completely pure substance. Does anybody know why this one is ironic for using it as an example of copper?
That penny's not 100% copper.
Yeah, it's not only not 100% copper. Yeah, it has like a few percentage of copper. It's almost all not copper. You'd be better off calling it zinc. Okay, so this right here is a compound. This is like water. Okay, you can get pretty pure water, though the water in your tap is not that pure. Okay, and purposefully so. You would actually not want to drink pure water. It tastes awful. Okay, it tastes kind of oily. It's very weird tasting. If you ever drink distilled water, that's closer to pure water, and it doesn't taste very good, right? Yeah. So this right here is mixtures. Again, you can have pure substances or mixtures. Mixtures are going to be things where you have elements and compounds that are physically mixed together. Okay? And so, for example, there is homogeneous mixtures. That's the way the Americans, this side of the Atlantic, says it. And that would be things like copper and zinc mixed together, which gives you brass. Okay? That's why it's the brass band or the brass section. Over here we have a heterogeneous mixture. Do you see how you can see the difference between the two with your eyes? There's pennies on the bottom and water on top. Okay? That's why it's called heterogeneous. Different, right? Hetero, different. Homogeneous, on the other hand, you can't see the difference between the individual spots in the mixture. And so homogeneous meaning homo same, right? Yeah. Okay. Does anybody know how to say it in the other side of the Atlantic? Yep. Homogeneous. And this one? Heterogeneous. Yeah, that's how you say that. Okay, now that we can go to Europe and communicate with them, or actually anywhere else but like the U.S., and people have been taught by the U.S. So the pure substance is classified as a type of matter with a fixed or definite composition, an element that is composed of one type of atom. A compound is going to be composed of two or more elements and will always be combined in the same proportion. This is very important. Has anybody ever heard of carbon dioxide? Yes. Okay. Yeah. Everywhere on the news, everywhere you look at, right? Okay, so have I told the story of Greenpeace and how the carbon dioxide from plants is different than the carbon dioxide from a vehicle? I have not. Okay, so Greenpeace, a multi-billion-dollar organization that does environmentalism, supposedly, has had on their website for decades that somehow the carbon dioxide that comes out of a car, the carbon dioxide that comes out of a human when you breathe, and the carbon dioxide that comes off of the rainforest are different. The carbon dioxide from humans and cars is harmful. The carbon dioxide from the rainforest is not. This is not true because the carbon dioxide is the same compound no matter where. Okay? It's the same harmfulness, it's the same. All right?
Yeah, two things. One, I think the point of that isn't that it's harmful, it's that we're producing way too much of it without anything else to balance it.
No. They specifically said that the carbon dioxide is different, and the carbon dioxide from volcanoes, natural sources that are not human, is somehow beneficial and not harmful.
Okay.
Yeah.
Second
Yeah.
thing.
They just don't know the chemistry.
Hearing about Greenpeace and chemistry, the carbon dioxide and all that, made me think of all those old stories about that huge hole in the ozone layer in the Antarctic, but then people just stopped talking about it. What happened to that? Did we fix that? Is that still going?
Yeah, so that was actually the only successful, it's called the Montreal Protocol. It's the only successful environmentalism that's ever been done that's actually been successful. And that ozone is largely healed. It had a slight resurgence back in 2020, but it's almost completely healed now. And it's looking like it'll completely heal by 2030.
We cleaned up our act and fixed it.
Not really.
Well, we made it better.
We did. What's happened is they paid Chinese companies to destroy ozone-depleting gases, and the Chinese companies are the same ones that make them. And so the Chinese companies actually now hold the world by ransom, threatening to release the ozone-destroying gases.
Do you understand
So, anyways, it's an evolving situation. The big thing that helped fix it is they actually made a set of replacement gases that was cheaper. Yeah.
You said that was the only successful Apple environment that is.
Yep.
Maybe for the second, we can finally clean up the great garbage.
So that's actually. Anyways, we should talk about it sometime. We got to move on with this, but come talk to me sometime. That's actually kind of an interesting thing. Yeah. You haven't actually seen the real one, probably. The one they. Anyways, let's get back to doing lecture. So, for example, your aluminum cans, those would be pure substances. Come on, everybody. Back to lecture. Okay, the aluminum cans, this is going to be pure substances, right? If we look inside the aluminum can, that's going to start being a mixture, isn't it? It's a mixture of sugar, it's a mixture of water, it's a mixture of carbon dioxide if it's a soft drink. Okay? So this right here, elements, these are going to be pure substances. They're going to contain only one type of material. And these are just some more examples: lead, copper, aluminum. Compounds consist of two or more elements. They're going to be chemically combined into a definite ratio. Those will be things like hydrogen peroxide, table salt, sugar, water. These are all compounds. Many of the things that you're surrounded with or made of are compounds. Okay. Table salt, this is actually a compound that consists of the elements sodium and chlorine. This is actually chlorine gas right here. This is sodium metal. You can see that table salt does not look like that, does it? No. And so that's actually sodium chloride combined into table salt. Okay. Mixtures. This is actually an example of a mixture. Spaghetti and water, right? It's a mixture between spaghetti and water. So two or more substances physically mixed, not chemically combined. If they're chemically combined, they would be a compound, wouldn't they? So two or more substances in different proportions that can be separated by physical means. Spaghettis is a mixture. Once we separate them with a strainer, we have separated our mixture, haven't we? Yeah. And so this is another way of doing that. You can think of it a bit like a coffee filter. This is called filtration, right? And so if you brew coffee or make tea, you're doing the same thing. You're doing a filtration. You're using filter paper, actually. Okay? Like a coffee filter, right? Okay, and so this right here has solid particles suspended in water. We pour this into the filter paper. The solid stays on top of the filter paper. The water is going to go through because it's smaller than the size of the weave of the filter paper, right? Okay. And this right here is called chromatography. Anybody ever taken like a paper towel and dipped it in liquid? And the water moves up it, right? Well, anything that can dissolve in the water is also going to move with that, isn't it? Okay, and that's what you're doing here. So you have ink specifically. Here we have a solvent that will dissolve the ink. And so what's happening is the components that are more soluble in the solvent are going to move up this faster. You can do this with like an Expo marker at home, dot it on a paper towel, put the paper towel in water so it doesn't submerge your dot, and it will move up and separate the different components of the Expo marker. Works best with like a black marker because the black markers get all the other markers thrown in. Yeah. And so we're actually seeing that separation happening, and we'll let it go up and it'll separate more and more. Okay, thank you. Okay. So this right here is the different types of mixtures. We have homogeneous mixtures, and for example, the brass instrument we looked at before. And you can't see the difference in homogeneous mixtures. Can anybody tell me a homogeneous mixture?
Brass.
That was a good one. Yep, you got me. Any other ones?
Is water homogeneous?
It is. For example, would you mind holding up your water bottle for me? Thank you. The water in the water bottle. That one's homogeneous. Could you hold up your tea? The tea in the water bottle again. Homogeneous. Is that tea?
It was tea. Yeah, it was raspberry tea.
Okay, I thought it was, but
I just thought of something. Coffee is coffee homogeneous? Yes, it's water, but you filter coffee grinds through it. Is it still homogeneous?
Yes, unless you end up with the solid coming down on the bottom.
Wow. No.
Then that would be heterogeneous. But yeah, if it's just the liquid, if you put cream in it and it mixes and it combines together, like mine has cream,
Mine has to.
yep, that's again homogeneous. Okay. Scuba breathing mixtures, these are also homogeneous. Anybody know why you don't want all oxygen?
Because it would because you can't properly breathe. Because you can't properly breathe. And plus, when you go too deep down, breathing like normal air actually becomes toxic due to pressure.
Yeah, you actually have to change your mixtures as you go deeper and deeper. Yep, due to the density and the pressure going on you. And so that's actually what you're seeing here, different types of mixtures. And these would get changed depending on how deep you're going. Okay? They usually have a valve to do the mixture. Anyways, by the way, a pure oxygen tank is actually pretty explosive as well. And can cause a lot of problems in that category as well. So let's talk about some heterogeneous mixtures. Gases are almost always homogeneous mixtures. That's why you don't see any differences around you. So heterogeneous mixtures, the composition is going to vary from one part of the mixture to another. Please don't talk a bunch on the side because it makes it very difficult. Then I have to yell really loud, and then it really hurts my voice. Okay? So if you have a heterogeneous mixture, what's going to happen is you'll have different parts you can see the differences of, right? Can anybody tell me a heterogeneous mixture? Not brass. Brass is a homogeneous mixture.
Water with a pen.
Water with a pen in it, yeah. Huh? Water and oil, exactly. Or like a salad dressing, those emulsions. Yeah. Alternatively, we could look a little bit closer to home. The desk in front of you is a heterogeneous mixture, isn't it? See the differences? Striations. The tiles above you, heterogeneous mixture again, right? See the different little things in it? My cup here, heterogeneous mixture, right? So you can see the little patches and differences. Okay? It's a wheatgrass cup in case you're curious. It's made out of wheatgrass. It's not plastic. I know. It can be compostable. Yeah. And it breaks down. Okay, so homogeneous mixture, by the way, the desk legs here, right? That paint on them is a homogeneous mixture. The metal is probably a homogeneous mixture as well. Likely steel. Okay, so identify each of the following as a pure substance or a mixture. The last one we're going to do as a plicker. So please get out your plicker cards, set them upside down.
Do you think this will work?
Yeah, it almost certainly will. Yeah. We can test it, though, in just a second. By the way, the plickers are going to be much better incorporated starting on the next chapter. I just couldn't do this chapter. Yeah. Because we're already parts of it in different classes. Yeah. Okay. Whoops. It's weird how that happened. Okay. All right, so pasta and tomato sauce. What type of thing is that? Is it a pure substance or a mixture? Mixture. Very good. Aluminum foil.
Pure substance.
Yeah, pure substance. It's probably about as close you're going to get to a pure substance in everyday life. Because aluminum is very pure, actually. Helium.
Pure substance.
Also pure substance. Okay, this last one, it's going to be pure substance A, mixture B. Okay? You ready for it? Air. Is it pure substance A, mixture B? Here we go.
A pure substance, B mixture. Is this good?
Okay, everybody see their things go off? Please shift your hands if you didn't see it. There you go. Okay. Okay, so what it was a mixture. Okay? Specifically, its primarily components is nitrogen, 70%, about 71% actually, and oxygen, 21%. Okay? Yep, and there we go. So, when we talk about our atmosphere, what is our atmosphere actually mostly composed of?
Nitrogen.
Nitrogen. And so we are a nitrogen atmosphere. Which every sci-fi movie says nitrogen atmospheres are poisonous to humans.
Maybe they mean pure nitrogen.
They mean ammonia. Yeah. They meant an ammonia atmosphere, which like Titan and stuff, and some of the moons are.
Hold on, actually, to be fair, wouldn't any atmosphere made up entirely out of any single gas automatically be poisonous? I mean, I can't even pure
So
oxygen.
technically, pure oxygen would not be necessarily poisonous. It would just be highly flammable. Yeah, so we'd be bursting into flames all the time.
Yeah, any kind of pure
Okay.
atmosphere would be obviously flammable.
What time is it?
You got 10 minutes.
Oh, okay. Identify each of the following as homogeneous or heterogeneous mixture. Hot fudge sundae. Is it heterogeneous or homogeneous?
That's not one thing, heterogeneous.
Okay. Yeah, can you see differences in the sundae?
Yeah.
Yeah, so it's a heterogeneous, right? Has to be. If it's a homogeneous mixture, that's a terrible sundae. That'd be so gross, right? Exactly. Yeah. I guess yeah. Anyways.
You can still separate.
Yeah, they don't quite mix, right? Because there should be like nuts or bananas or stuff like that. So baby shampoo. Homogeneous, unless you're getting really, really crazy with this baby shampoo. There is the ones with like the scrubbing bead things in them or whatever. Shea butter, I don't know. Anyways, that seems like a terrible idea for a baby shampoo. All right, sugar water. Homogeneous, you got it. Peach pie. Heterogeneous. Again, that sounds disgusting as a homogeneous mixture, doesn't it?
Makes me those grocery store pies.
Maybe. Ugh. Solids. Okay, so now we're going down, and these are the phases of matter, right? Anybody know the phases of matter?
Solid,
Yep.
liquid, and plasma.
Solid, liquid, gas, or whatever order you guys want. I heard a bunch of different orders, but
Plasma.
you got it. Plasma is a phase of matter, yeah. And you can actually encounter it on Earth. However, if you were to directly encounter plasma so that you could actually like mess with it, as a natural phenomenon on Earth, you would be dead. Because the main place where plasma is going to be made, does anybody know?
Core.
Not in the core, actually. It doesn't particularly happen in the core.
It's a volcano.
Not a volcano. Those are actually lava, but in reality, lava is actually just more like Play-Doh. It's not liquidy. Okay? It's just a solid. That's it.
It's a magical salt.
Does that mean
Yeah.
does that mean that if you theoretically had both the heat resistance and the strength to play around with molten rock, you could play with lava like Play-Doh?
Yeah. Oh, yeah. Big time. It would require a lot of strength because it's a lot more dense. But, yeah. Oh, yeah. And the only reason it flows when it gets to the surface, it doesn't really flow very well. It's just because it's being extruded from a very high pressure. So, have you guys ever seen the Play-Doh thing that you can press down on the lever and it goes psh? That's a volcano. That's all a volcano is. It's just very hot. It's lightning. Lightning actually creates plasma. If you ever see those flickering bursts of light that happen between the lightning bursts, those are plasma discharges. Okay? It is not. Though a very, very hot fire can create plasma, yes. Fire is actually just release of light from a gas. And so you can actually create plasma, though, on like a very hot fire. But it has to get pretty hot. Yeah. So solids have a definite shape. They have a definite volume. That's why your desk is staying in the same shape. It's not changing, is it? And your desk is not filling the room. It doesn't continuously expand to fill the room, does it? Nope. Its particles are going to be held together very closely by strong attractive forces. That's why the particles are trapped in place and they can't move around to fill the container, right? Okay. And so they can't move around to change shape again because they're trapped in place. Kind of like if you all held hands, all of you, you won't be able to move around, right?
No.
Okay, no activities where you all hold hands. So particles are arranged in a rigid pattern. They can only vibrate slowly in fixed positions, and that's how what particles actually look like if you look into a solid. They have like these particles that are vibrating like this, but they can't really move around much. They're contained. Liquids, so these are going to have a definite volume. That's why my coffee hasn't expanded to fill the room yet, has it? Okay, that'll be interesting because I drink pretty concentrated coffee. They do not have a definite shape, though. If you look down in your containers, you can actually see that they basically conform to the shape of the container, right? Their particles are going to move slowly in random directions. Think of it about like this. A solid has 100%, everything's connected, and so they can't move around well. You get down to a liquid, you break about 20% of those connections repeatedly over time, and what happens is you can start shifting around, right? Okay. You can actually do it with your hand. Break like 20% of the connections, you can start moving your hands around, right? Reconnect, and then break some more connections, and you can move around more, right? Okay. And that's a liquid. Gases, these are going to have an indefinite shape. They don't have any given shape that they're going to maintain. They have an indefinite volume as well. They're going to expand out to fill whatever container you're in. The shape and volume as their container. Whatever the container is, that's the shape and volume of the gas. The particles of a gas are very far apart, and they're moving really fast. Think of it kind of like you all in the hallway right before classes. You're all zooming everywhere in the university, and so most of you don't have time to like shake hands and, hey, how you doing? You can't interact well, right? Same thing with the gas. There are a little bit of interactions, but for the most part, most gases, no real interaction. They're moving too fast, too far apart. Okay? Does anybody know if the Earth is a closed system? You ever heard of Spaceship Earth? No, it's not a closed system. We lose gas to space every now and then. It's not a huge amount, but we do. And then we also gain new stuff. The biggest one being the sun. We're constantly gaining an influx of particles from it and light, of course, and energy. The majority of the energy on the planet, right? Okay. So how much time do I have? 3 minutes? Okay, basically this then. Identify the state of matter for each of the following. Vitamin tablets. Solid. Very good. Eye drops. Liquid. Excellent. Vegetable oil. Liquid. Excellent. Candle. Solid. Very good. Air in a basketball. Gas. Excellent. Okay, you all have a great day. We'll start up next time on physical properties. Yeah, if anybody wants to talk about like environmentalism stuff too, it's actually quite interesting.
Yeah, you remember I'm leaving tomorrow
Uh-huh.
and coming back after 2 weeks.
Okay, fantastic. Yeah, what will happen is whenever the exam starts coming along,
Yeah.
I'll just have you take that when you get back, okay?
Okay, I'm supposed to be back to the US on 22nd
Okay.
of this month. Yeah.
Okay. Is this your, oh, you don't have to answer this, actually.
Yeah, no, I'm fine.
Is this your visa renewal or?
No, I'm citizen and I'm
Oh,
for
okay.
investment.
Oh, just invest. Okay,
Yeah,
cool.
I'm partner with some friend and we investing and make sure.
Okay.
Yeah, for the
Yeah.
future.
The reason I wanted to ask is sometimes those visa renewals
No.
are rough,
I'm
right?
going to passport.
But fantastic. Citizen, you don't have any problems
Yeah, I'm
with
going to Togo, Ghana, and Nigeria.
that. Oh, cool.
Yeah.
Cool.
Nice.
That'll be interesting. Yeah, just keep me up to date.
Okay.
Okay.
Thank you.
And if you need any office hours or anything, we can
Can
Zoom.
we zoom in? Okay. Thank
Yeah.
you.
And just let me know. I'll try to work with you on the schedule and stuff, okay?
Appreciate it.
It's so weird to have students the same age.
No, no.
Okay, I was gonna
I
ask.
don't think we're the same age, though.
No,
talking about him.
Oh, him? Yeah, no, no.
He's probably your age.
Oh, no, I've had students in their 60s. Yeah.
How old are you?
I'm 39.
Question. 12 o'clock, is that okay to meet?
Oh, yeah.
Okay,
Yeah,
I just
go
want
for
to
it.
make sure.
That'd be
Okay.
fantastic.
Okay, perfect.
Okay.
Awesome.
Yeah, and we'll sit down, and honestly, it's going to be something where it's like one or two problems. What the hell's going on with this? And then once we get the things worked out on those, you're going to be like, Dr. Clausen, I'm embarrassed. And it's not something to be embarrassed about.
Okay.
Just keep that in mind, okay?
I'm like not for sure where to put him and how to work him.
I was adding too many carbons onto one of my things, and I'm like, hey, and it was like, cool, got it.
Yeah. Yeah,
I was
it's,
just lost. I tried to YouTube it last night. I worked all day. I didn't have to work, so I had all day to try to work. I was
Oh,
like, I cannot.
don't do that with a problem. Once you get 10, 15 minutes in, if you're not making
Well, I
any
skipped
progress on
around.
it, okay.
And I'm just so lost.
Just
with the
write
problems.
those problems that you're having trouble with, and then come into me. If you can't come into me, tutor would be the next
Yeah.
best.
Yeah, I did. I had like an online like tutor thing. They're supposed to like set one up because I have to go to work at 1. So.
Okay.
I hang out to 1 and work on this, but yeah.
We'll work on it.
Okay,
Yeah, you
awesome.
just need somebody to go through your work and be like, this is where you went off.
Okay, perfect.
How,
Thanks.
how late are you available, out of curiosity?
I am available this entire time.
Till when?
Until 4 p.m.
2 to 4.
You got me.
I saw it up on the screen.
Then I'll
Thank you.
I'll probably just have to email you then because I won't be able to be available till like 5ish, unfortunately, because
Okay.
we got to do it. But
I also typically do some like office hour stuff at 7 to 8.
PM?
Yeah.
Oh, perfect.
So,
that'll work good.
If you message me, I can try to arrange, okay?
That'll work because I'll be at work till 11:30 tonight.
Okay. Okay. The other thing is we can do asynchronous as well,
Yeah.
where you send me a picture of like your work.
Yeah, and then you reply and go back.
Yeah.
I have a couple chemists that I work with that have been helping me. That's why I'm like, oh, this makes sense. My boss's girlfriend who works at the company does chemistry for a living, so
Yeah,
It
they're
helps.
probably like, yeah,
so
What do you mean getting something?
Like, or do we have 5 minutes, 10 minutes?
Oh, okay. Well, I have to be somewhere 11:30, so I guess we have like 10.
Okay. Okay, because.
10,
Okay.
15 minutes.
So.
And at first, I didn't really understand the piercing thing at first. And it actually
Okay.
glitched on me.
So what you need to do, apparently, is go through Vital Source first. Okay, and you can actually go right here.
Oh, sorry.
It's okay. And where's the
Right here?
Vital Source? There it is. Mm-hmm.
Okay.
Okay, and then reveal access code. Okay, and then copy that. Mm-hmm.
Okay.
Okay, and then let's go to Pearson.
Right here? Okay.
Excuse me.
No, you're fine. And then open.
Mm-hmm. Okay, and then you'll go into which one is it here?
It's touchscreen too, so you
More.
tap it if you want.
I think it is. These are settings, probably. That did not do it, did it? All right. Mastering chemistry.
That's it.
You may have to go through Pearson itself, or actually call them up, because I have never actually had to put in the code for somebody here. Okay. Okay. Do you know where it shows that you're temporary access?
Mm-mm.
I'm not seeing it.
No, and I did call him, and at first it didn't let me go in it.
Let me see if you're even temporary access, or if you've already been activated.